If I burn 2 litres of hydrogen gas and 1 litre of oxygen gas, I find that I have 2 litres of water vapour. But I started with 3 litres of gas. Why was there a change? Well, in 1811, Amedeo Avogadro offered an explanation.
Avogadro hypothesized that equal volumes of gas contained equal numbers of molecules, and further, that the volume of a gas is directly proportional to the number of molecules in that gas. That is, V is proportional to N, where N is the amount of gas, measured in moles. Avogadro was inspired to formulate this law by Joseph Gay-Lussac's publication of the Law of Combining Gases, which states that the ratios of the initial and final volumes of any reacting gases can be expressed using whole numbers. Although he never used the word atom, Avogadro was the first to recognize the distinction between elements and the molecules they form. He proposed that each molecule of gases such as hydrogen, oxygen, and nitrogen contained 2 elemental particles. He said that, for instance, when hydrogen reacted with oxygen, the hydrogen and oxygen atoms split from one another in their corresponding gases and recombined to form water molecules. Hence, when 2 litres of hydrogen and 1 litre of oxygen are combined, using the corresponding chemical equation, there are 2/3 fewer molecules remaining, and hence by Avogadro's law the final volume of water vapour is only 2 litres. Unfortunately, agreement with Avogadro's hypothesis was not widespread until after his death. André-Marie Ampère published the results of an experiment which made the same conclusion as Avogadro 3 years later, but it too was rejected by the scientific community of the time. Suppose that we have a container with a movable piston. Initially this container has a volume of 1.8 litres and is filled with 0.7 moles of oxygen gas. The piston is allowed to move so that the pressure remains constant, as 16 additional grams of oxygen gas is added. What is the new volume of the piston? If 16 grams of oxygen is added, we can divide by the molar mass of oxygen to find that 0.5 moles of oxygen was added. Then, recalling Avogadro's law, we have that the initial volume divided by the initial number of moles is equal to the final volume divided by the final number of moles. Rearranging, we have that the final volume is equal to the initial volume multiplied by the final number of moles divided by the initial number of moles. Substituting in values, we have that the final volume is equal to 3 litres.
The solution to this problem would be useful if a gas transportation company needed to increase the mass of gas each of their trucks carried, but couldn't increase the pressure of the vessels. It would tell them the volume of the larger tanks which they needed. Avogadro was educated as a lawyer, but became increasingly interested in science. He grew up in a time when Galileo and Newton were the most prominent scientists of the day, and he was inspired by their works. By the age of 33, Avogadro was teaching physics at a school in Vercelli, the city where his family lived. Despite his distance from research being conducted in Northern Europe, he published his hypothesis in 1811, after being inspired by Gay-Lussac. In 1820, he was working as professor of physics at the University of Turin, where he taught for more than 20 years. Avogadro also wrote papers on weather forecasting, statistics, and systems of measurement, and of course, he is a universal constant which is named in his honor. This all begs the question, what did Avogadro teach his students in math class? Probably multiplication.